Hello aspirants, welcome to our online education platform Vivekananda Vigyan Charcha. Today we are going to learn about the second part of the redox reaction, and that is modern concept of redox reaction. Let's start the lecture. So students, again recap the last lecture. Once again, only oxidation and reduction part. So in case of oxidation, we got to know that addition of oxygen or electro positive elements, yes, right, and elimination of hydrogen or electronegative elements, and in case of reduction, just opposite of oxidation. Here will be addition, for oxidation it will be electronegative elements. Okay students, for reduction, addition of hydrogen or electropositive elements and elimination of oxygen or electronegative elements. This is the classical concept for redox reaction, but in nowadays we don't use this concept. Okay students, so let's see what modern concept of redox reactions say. Modern concept of redox reaction, it states that transfer of electrons from one species to another, or transfer of electrons between two species. Okay, means the reactant side and the product side, the electrons of any species will be vary. Okay students, let's check it out. In this reaction, that is, yes students, in this reaction, Zn plus HCl gives ZnCl2 plus H2. Let's see this in classical way, means the classical method of the redox reaction. See, for Zn, here becomes ZnCl2. Chlorine is electronegative elements, and addition of electronegative elements means it is oxidation. Yes students, and here HCl, and in the reactant side it is HCl, and in product side it is H2. That means elimination of electronegative element. That means reduction. This is the classical way we used to learn. Yes students, but I will show you the modern concept of redox reaction with the help of this same example. Before going to the modern concept of redox reaction, let's see one funda, how to remember the oxidation and reduction in modern concept of redox reaction. In lower classes, means at the beginning of the chemistry, learning about the chemistry, about the atoms, you learn that atom consists of three subparticles. Yes, that is proton, electron and neutron. For electron we denote minus sign, negative. For proton we denote plus sign, and for neutron that is 0. Yes, let's write it like this, 0 and plus. Yes, this we learn, that is negative, neutral and positive. Okay students, now see what happens. If it is minus to plus sign, listen very carefully. If the electron transfer is minus to plus sign, take it as the number -1, 0, +1, +2, +3, like this way. Okay, here don't mix up with the electrons and the oxidation number. I am talking about the oxidation number. Yes, I am teaching you with the help of the electrons, but it is oxidation number, that is the charges. If the charge is from minus to plus, that means increasing, it will be oxidation. Okay students, that is -2, -1, 0, +1, +2. If in the reactant side it is like this, it is -2. Yes, and in the let it take -3, -4. Okay, -4. And in the product side it is -1. That means it is increasing, -4 to -1. That means it is oxidation. Okay, and if it is opposite, it will be reduction. See, from the name only, reduction, that means reducing. Yes students, from name only we are getting that it is reducing the charges. That means if any of the charges of, let it take +6 in reactant side, and it becomes +2 in product side, or -1, it may be happen. That time it will be reduction. Okay students, such as for chlorine, if in reactant side, if the chlorine is in +5 state, yes, and in product side it become Cl, and that is of -1 charge. See, from plus to negative. Yes, that means it is reduction. And if it is happen like this, in reactant side chlorine is of -1, and in product side it becomes +3. It is all the oxidation number, that means charges of the species. That means it is increasing. See, -1 to +3, increasing, that means it is oxidation. Okay students, by this way we will check it out in each of the example, that in reactant side each species carries what oxidation number, and in product side each species carry what oxidation number or charges, and by that calculation we will check it out, the reduction and the oxidation. Okay students, let's see the previous example only. And remember one thing, for the neutral case, that is 0, when any species will be 0, when the atom is not pairing with any other atom to form a compound, such as, let's see here only, here zinc, Zn, yes, HCl. See, HCl has 2 atoms, yes, that means it carries charges, but here zinc is free, it is one element only, no compound, that means it has 0 charges. And here H2, for hydrogen also in peroxide, it is element, hydrogen molecule, yes, it is it will be also 0, no charges. But here we will see HCl and ZnCl. See, for chlorine we know -1, and for HCl we know +1. Yes, right? And for zinc and chlorine, let's check it out. If you forgot the charge of zinc, don't worry. Just remember what charges chlorine carry. That is -1. Let's put up here -1. See, -1 into 2. How many chlorine is present in peroxide? 2 chlorine is present. Yes, right? That means -1 into 2 equals to -2. That means here total in the peroxide, total chlorine is of -2. Yes. So to neutralize it, that means to make it 0, we need +2. Yes, right? -2 plus 2 becomes 0. Yes, students, we know. So that means zinc carries +2 charges. Oxidation number is +2. Okay, students? See, +2. Here chlorine, 2 chlorine is present. -1, 2 into -1, -2, and +2 -2, 0. Okay, students, now we will see the oxidation under reduction. The game of the oxidation under reduction. See, zinc is 0, and what it becomes in the peroxide? +2. Yes, right? And here, see, I am showing the method. After taking out the charges or the oxidation number, let's see which elements or the species having the same oxidation number or charges in both the side. Means in the reactant and the peroxide, both charges are same, of that same species. See, chlorine, yes, Cl and Cl both having the same charges, that is -1. So cancel it out. So we will carry the half reduction and oxidation method. Zn becomes Zn2 plus. Yes, and H plus 1 becomes H2. Yes. So here zinc is 0, here H2 is 0. See, now we learned that if any charges or oxidation number increases, that means from minus to plus or 0 to plus, it will be oxidation. Yes, right, students? And if any charges is decreasing, that means from plus to 0 to minus, it will be reduction. See, from plus to 0, that means it is reduction. Okay, students, understand? This is the halfway method. You can show it like this also. Arrow. It will be oxidation, it will be reduction. Okay, students, understand? Let's see another example. See, carbon dioxide. See, carbon and oxygen in the reactant side, both are in the molecular form. That means 0 charge carrying. So put it 0. But here we don't know the charge of carbon. How we will know? Because carbon is not any ion, it is a covalent compound. But don't mess up here. Ion is different and oxidation number is different. Okay, the charge of ion is different and the charge species of the oxidation number, that what we say oxidation number, that is different. We are talking about the oxidation number, not the charge of any ion. Okay, students, so we know the charge of oxygen. Yes, that is minus 2. Right or wrong? Right, students? So now let's see. To make it 0, we need to calculate. See how many oxygen is present here? 2 oxygen. That means minus 2 into 2 becomes minus 4. Yes, students? And this minus 4, to make it 0, we need plus 4. Yes, right? So to make this compound 0 charge, carbon should carry plus 4 charge. Yes, right or wrong? Right? Okay, students? Now let's see. Carbon, oxygen. Now see, students. In the reactant side, carbon oxidation number is 0, but in the product side it is plus 4. That means it is increasing. That means it is oxidation. And here oxygen in reactant side it is 0, but in the product side it becomes minus 2. That means it is decreasing, and decreasing means reduction. Yes, reducing, oxidation number gets reduced. That means reduction. And if anyone asks you that which one is reducing agent and oxidizing agent, that means reductant and oxidant. For oxidation, carbon is reductant, and for reduction, oxygen is oxidant. Okay, students, understand? By redox reaction, we can balance any reaction. Let's see one example. See, MnO2 HCl plus HCl become MnCl2 plus Cl2 plus H2. Let's quickly write the charges. For oxygen, minus 2. And manganese will be how much? Minus 2 into 2 minus 4, that means plus 4. HCl minus 1 plus 1. Here MnCl2. Quickly say, for chlorine minus 1, that means minus 1 into 2, what? Minus 2. And to make it 0, we need plus 2. Here chlorine alone, so it will be 0. For hydrogen, we know plus 1. Plus 1 into 2, plus 2, and to make it 0, we need minus 2. So oxygen is minus 2. Yes, students? Now let's see. How to balance it. How many chlorine is present in the product side? Cl2, Cl2, that is 4Cl. Yes, minus 4, here will be also 4. But here since 4 HCl and 4 hydrogen is present in HCl, so in the product side also we need 4 hydrogen, but here only 2, so we need 2. See, balanced. 2 oxygen, 2 oxygen. Now let's check it out. MnO2 becomes MnCl2, that is plus 4 to plus 2, and Cl, yes, oxygen gets cancelled out. Now we will, and hydrogen also. Here we will take this Cl, where the chlorine is getting the oxidation number is changing, we will take that one. So here minus 1 to 0, that is it is increasing, that is oxidation. And here it is decreasing, plus 4 to plus 2, reducing, that means reduction. So students, understand? In the higher classes we will learn more about the redox reaction in 11, and we will learn how to balance any chemical reaction, and we will get into more details about the oxidation number and many more magic in this redox reaction. So for today up to this much. So here we ends the topic about the different types of chemical reaction. Okay students, please like the video, share it and comment down what you want to know in chemistry about the next topic, and please don't forget to subscribe our channel. Thank you students, hope you enjoy the video and happy new year in advance. Thank you students.